Hello and welcome to SudoKanard. We're here to solve this multivariant puzzle, extra region, quadruple, little killer Sudoku by Jan Vondruška. This was a puzzle in this famous round 5 of Czech Sudoku Championship, and it mixes three variants that we've already seen: extra region, which means that those cells form a region. Those shaded cells contain all digits from 1 to 9 exactly once. Same for this Z-shaped region. And then we have a little killer. Those 3 cells sum to 13. Those 4 cells sum to 27, and so on. And we have quadruples. So those digits are 2, 3, 5, 9, and so on. So when I test solved the puzzle, it took me 16 minutes to solve it, which means that there is quite some work to do in here. So where do we start? I think a place to start is to note that 2, 3, 8, and this is 6. I have trouble seeing. This is a bit too small for my liking. So this is 2, 3, 6, 9. So they are not in here, but they must be in this region. So they must be the same as those digits. Oops, what did I do? Not here. So those are 2, 3, 6, 9. And something else is that here we have 2, 3, 9, which means that 2, 3, and 9 do not appear in those cells, so that they must be here. And we have the same at the bottom with 1, 4, and 7. They are nowhere to be seen in here, so they must be there. Now 7 here would be too big. Oh, yes, they would be too big, because here only 1 and 4 would make this 12, which would be low enough, but then we will need a 1 to get to 13, and 1 would be repeated in this region, so that doesn't work. This is probably not a needed step, but I'm just stating it anyway. Now what about this? Not sure. Where? Oh, this 10. 9 will never be part of this 10. Here, if I try 2, 5, I could still have 2 and 1, so that seems to work. But 9 will never be along this. So those are from 2, 3, 5. But an important point is that if 5 is here, then we need 2, 2, and 1. Note that the minimum value here is with 2, 2, 3, which is 7, so that the maximum value here is 3. And 21 here, this can't be 1 or 2, it would be too low, so this is 4 or 7. 4 would come with 8 and 9, 7 would come with 5, 9, or 6, 8. All of those are possible at this point. There is a 2 in here and a 2 in there, so there's no 2 in here, meaning that 2 must be somewhere here, so we can exclude 2 from those. There is a 9 here and a 9 there, so by the same logic, 9 is nowhere here, so 9 must appear somewhere in there. And this is kind of interesting, because 9 will never... 9 is too big for this 13 clue to hold. So 9 will be here after all. 9 is nowhere in here, so that is a 2, this is a 9. And 9 is not in those cells, so they are from 1, 4, 7. And there again, if I try to put the 7 in here, does it work? Could it be 7, 1, 1? This is 9, and 4 there. That seems to work. Actually, yes. If this were to be 4, and 7 here wouldn't work, we would have a total of 9, and this would have to be a 4, which would repeat in the shaded area. So that doesn't work. This is 1. So now those 3 digits must sum to 12. And while 2 of them are from 147, the third one must be the third digit from 147. I don't remember doing this logic earlier. So 9 won't work here. Those 2 would have to be 1. So this is 9. This is 1, 4, or 7. And this is the same digit as that. 7 here would require those to be 1 and 3, which is forbidden because 1 is around here. So that's not 7. So this digit is the same as that. And now how do we guarantee that this is 11? If I try to put a 4 here, then those 2 must sum to 7, and they can be 2 and 5. So this works. And with 1, they must sum to 10. It could be 2 and 8. So this still needs some work. There are 2 8s in here, 2 6s in here. And with that, there has to be a 6 somewhere here, which means that 6, that's interesting. 2, 3, and 6 are not here. They are in none of those cells. So in this Z-shaped area, 2, 3, and 6 must be here. And we complete this extra region with 5 and 8. And this is 147. And this is 5 and 8. And at the bottom, this is 5, 8, 9. That's not 9. And we need 3 and 6 somewhere in this region. I've been missing this. There's a 1, 4, 7 triple, in which 1 is in there. So that's not 1. And this can only be a 2. Three here is too low for this 21 sum, so that's a 6. Those 2 now must sum, must sum to 15, so that is 7, this is 8, 9. So here, there's an 8 in here, so this is 5, this is 8. And here we need 2, 3, and 8. 8 is not here. Here we need 5, 6, 9. But the 6s are in here, so 6 goes there. Is there anything to do with this 17 clue? Those 3 cells sum to 15. This is not 8. 8 is up there. Actually, 8 can only be here. So this is from 147, I think. Yes, that's correct. Those 3 must sum to 15. So they could be, sorry, they could be 771 or 744. I'm saying that this digit is nowhere here, it must be there. Sorry, I must cough. All right, I hope that I won't be subject to any more coughing fit. Well, what was I saying? Oh, it was about having several decompositions of this. Now there's a 1-4 clue, 1-4 pair, sorry. So this is from 5 and 7. I've been missing this. 9 goes here in this quad. So 9 needs another 11 without using those digits, so it must be 4 and 7. So there's something about 1, 4, 7 everywhere in this grid. 8 goes there, and this is 1 and 6, which tells us that this is 4, this is 7, this is 4, this is 1, this is 4, and we can check that this 13 clue is satisfied. This is not 1 anymore, this is not 6 anymore, and this 11 clue needs a 2 here. That's 3, that's 6, no 2 here, so that's a 2, no 5 here, 6 goes there, and this is 7, that's a 2, those are 1 and 3. Now about this 10 clue, we already have 4, so this plus that must be 6, which means that this is 3, this is 3. And I still struggle to pronounce digit 3 after all that practice. Now, no, with those twos, that has to be a 2. 3, 6, and 9, so this is 6, this is 3, this is 9. 6 and 3 here. And this has to be from 5 and 7. For this 13 clue, this plus that must be 11. 6 is not available, so it will be 4 and 7. 5 here, not 4. 7 must be here. So this is 9, we did another 8. There are still 2 options, right? But 4 is not here, so 4 is there. 4, 1, this is 5. This 6 tells us that this is 1, this is 6, so this is 1, this is 8. 13 plus 4. All right, and for this 27, we already have 18, so this is 9. This is 2. Here I still need 4, 5, and 7. I think all the little killer clues are fulfilled. This is correct. Here I need 1, 6, and 8. So this is from 1, 8. 1, 6, 8, 6, 8. That's a 3, that's a 1. Here I need 2, 8, and 9. So this is from 2, 8, 8, 9, to 8, 9. Here I need 3, 5, and 6. And I'm definitely missing something here. This is not 7. I need to find new deductions. How does this resolve uniquely? And the answer is that there is a 4 here. This is not the answer. Now there's no 8 here because of that. Oh yes, There are two 8s here, so this is 1, this is 6, this is 8, that is 6. And because of this one, this is 7, this is 4, this is 1. So that's not 4, this is 4. This 3 here tells us that this is 2, this is 9, 8, 2, 8, 3. And we get the remaining digits. So it was what? I just don't understand. I will have to pause again and just check that the mistake I made was in preparing the Pampa interface and not in my soul. Well, what I did was correct. It was my Pampa interface was wrong. I will try to fix it before sharing it in the description. Anyway, thanks for watching this video and see you soon on SudoKanard.